Hello, this is Haifa Maamar, and today we'll be talking about tree traversals. There are some complex types of data that cannot be represented using a binary tree and are best represented using a non-binary tree. Before going further, let me first explain the difference between a binary tree and a non-binary tree. In a binary tree, nodes can have at most 2 children. Each node can have either 0, 1, or 2 children. In a non-binary tree, nodes have a variable number of children, so each node can have 0, 1, 2, or more children. These trees are called N-ary trees. If we look at the tree below, A has 3 children, B, C, and D. B has 2 children, E and F. E has only 1 child, I. C does not have any children, and D has 2 children, G and H. N-ary tree can be used in different examples. An N-ary tree can be used in an employee reporting hierarchy, where the supervisor is the parent, and members of his team are the children. Teams can consist, of course, of different number of people. An N-ary tree can also be used in the game path search graph, where each node is a step away from its parent. Let's consider a player at a specific position. From that position, the player can move forward, turn right, or turn left. So we have 3 children in this case. Of course, here I'm only considering movements. An N-ary tree can also be used in a directory structure, where files can vary per directory. And also, an N-ary tree can be used in a token tree for compiler when nodes represent syntax element. There are 2 types of traversals, depth first and breadth first. Let's start with the depth first. A depth first traversal starts at the root and visits the nodes in the tree as far down one branch as possible, visiting children first before reascending the tree to explore sibling nodes. In a depth first, we can proceed in pre-order, where the parent is visited first and then children are visited last, or in a post-order, where we visit first the children and parents are visited last. So let's consider this tree and let's perform a pre-order traversal. So we said in a pre-order traversal, parents are visited first. In this case, we start with A. So we process A. Then we visit his children, B, C, and D. So we start with B. B has 2 children, E and F. So we start with E. E has 1 child, I. Then we print I. Then we go to the siblings of E, F. We're done with the B subtree, let's call. Then we go to its sibling, C. C does not have any children, so we go to D. And then D has 2 children, G, and finally H. This is a pre-order traversal. In a post-order traversal, we start with the children and then parent are visited last. So in this case, we start with the leaf, I. I is visited first. And then I does not have any siblings, so we visit its parent, E. And then we visit the sibling of E, F. F. From there we go to the parent, B. And then we go to the sibling node, C. C does not have any children, so we're supposed to go to its sibling, to the D subtree. D has 2 children, so we start with G, then H. Then we visit D, the parent, and then finally we visit the root. Depth first can be implemented recursively or iteratively. Let's start with the recursive way. In this example, we're showing the post-order traversal. So the post-order traversal, we start with the root. For each child of the root children, we call again the post-order traversal with the parameter child. Once we hit the last one, then we process that node, let's say, or we print it in this case. If you know how the recursive way or how recursion work, actually you will get a post-order traversal where, if you remember the tree that we've seen, we start with I and then we go to if it has any siblings, otherwise we go to the parent and so on and keep doing it. In the second example, pre-order traversal is implemented iteratively. So depth first is actually implemented using a stack. So we start by adding the root to the stack, and then while the stack is not empty, we pop the first element, or we remove the first element of the stack, we assign it to the node, we process it. So let's say in this case we print it, and then we add the elements or the children of that node to the stack. So we push them to the stack. And we keep doing this. So in this case, if we follow the logic, we start with the root, we remove the root from the stack, we pop it, we process it, so we print it, and then we push the root's element, the root's children. So B, C, and D. We start with B, we pop it, then we print it, and then we push his children, and so on. And we keep doing it until we traverse the whole tree. And the second type of traversal, breadth first. In a breadth first traversal, we use a queue to traverse the nodes level by level. The parent is processed first, and then its children are added to the queue in turn. So if we take this example, or this tree, we said that we start by the parent and then we add its children. So in this case, we add A to the queue, we process it, we print it. Then we add his children, B, C, and G, to the queue. We start with B, we process it, and we print it. Then we add his children, E and F, to the queue. Here we're dealing with the queue, so his children will be added to the end of the queue. Then we process the next element, C. We print it. Then we process the next element, G. G has two children, G and H. We add them to the queue. Then we process the next element, E. E is printed. It has one child, I. We add it to the queue. Then we process the next element, F. F does not have any children. Then we process the next element, G. Print it, and then H. And then finally I. And this is a breadth first traversal. Breadth first traversal are usually implemented iteratively. And as I explained earlier, we use a queue to implement breadth first. So let's have a queue, and let's add the root to the queue. Then, while the queue is not empty, we remove the first element of the queue, and then we process it. So let's say we print it in this case. And then for each child of that node, for each child of that node children, we add them to the queue. So if we follow this logic, we start first with the root, then we remove the root from the queue, we process it, then for each child of the root, we add it to the queue, so we added B, C, and D, and then we process, and then we start again. So we remove B, and we process it, and we add his children to the queue, and we keep doing it until we traverse the whole queue. So this is a breadth first traversal.